In this fast track, we will see what a functional interface is in Java. A functional interface is one that has only one abstract method, meaning a method that must define the implementation of the interface. An example is the runnable interface. Starting from Java 8, this interface is considered functional because it has an abstract method called run. This interface is used to create threads within a Java program, that is, processes that run simultaneously within my program. In this case, the run method is always an abstract method, which means that when a class implements run enabled, it is required to define the behavior of run through an override using the @override notation, which is optional but is a good practice. In this case, starting from Java 8, this interface became a functional interface simply because it has only one abstract method. This means that when that becomes a functional interface, I can use it within a lambda expression. It is an essential requirement for it to function as a lambda expression. Previously, in order for me to use runnable, I had to create a class that implemented runnable and then override the run method. Now, being a functional interface, I can do it in a single line of code without the need to create the class, implement it, override, but in the same line of code, I would do the three things. Something like this. I say, enabler is the name of the object. In this case, my run method does not receive any parameters, so I can leave the parentheses empty and the implementation. In this case, the only thing the run method would do is print the word hello. This here is my lambda expression. Implementation parameters on the right side. I am assigning the result of this to an object of type runEnable. Another example is the comparator interface. This interface is sometimes used to sort arrays, lists, etc. It helps us to be able to make a comparison between the elements of the array. It has a method called compare. As it is the only abstract method it contains, it automatically becomes a functional interface. The functional interface annotation is optional, but I suggest that you add it as a good practice to make your code more readable. Again, having only one abstract method turns it into a functional interface, so I can use it as a lambda expression. As we can see here, at the bottom, I have the compare method, the implementation S1, S2, and the line that implements that comparison of the elements. Another way to see this same line would be if I had created an anonymous object of type comparator by overriding the compare method. That would have been another alternative, but obviously the code with lambda is much more concise and readable. So, as we said, it is necessary that in order to be able to use or express a lambda expression, I need it to be a functional interface. More details coming soon. I can have different types of functional interfaces. Basically, the difference is the types of parameters they accept and the return type. The predicate receives a parameter of type t and returns a true or a false. It is generally used for evaluation or filtering. For example, I just evaluate the condition and return true or false. A consumer is someone who accepts parameters but gives nothing in return. For example, system.out.println would print but actually does not return anything. A function receives two parameters and returns a third. A function is characterized by its main method being called apply. Supplier returns items without receiving anything in return. These four types of functional interfaces are important for us to have clear when presenting the Java certification, as they are questions that come up quite often in the exam. Understanding these concepts is crucial. That's what we mean by functional interface in Java.